On behalf of Atlas Copco Group, India, I would like to welcome you all to this webinar called Upgrade to Save to find out the most efficient approach for treating your effluent and wastewater. We cannot deny the fact and the importance of water for our business and for industrial purpose as well. And as per provision of Environmental Act 1986, treating this water before leaving into water bodies is must. Thus, having an effluent treatment more efficient and most promising, this session will be there conducted, and I will quickly touch upon the agendas that we are going to present in this webinar. Just a minute, I'm changing my slide. Can we have a slide change?
I've done that, Veronica.
Yeah. We will discuss upon a quick introduction about Atlas Copco, followed by the water treatment process and irrigation, and where does the blower plays a big role and how it will be efficient enough to go and upgrade yourself. And at the end of the session, we will also touch upon the questionnaires. So I would request you to put your questions in the chat below. We will touch upon this at the end of the session. In case of any time delay, we will surely follow this questionnaires through via mail and also give you the link at the end of the session. Thank you. I will call upon Saurav Chaudhary, the National Sales Manager for Low Pressure Business. He will lead us for the upcoming seminar. Thank you.
Thank you, Veronica. Thanks for the introduction. First of all, a very good morning and a warm welcome to the webinar. My name is Saurav Chaudhary. I'm the National Sales Manager for Low Pressure Business in Atlas Copco. In the next few minutes, we will just take you through the process of wastewater and the importance of aeration in that. And we will also look into it, what roles the Atlas Copco can play in there and what value addition we can bring in to your business in form of an energy efficient solution. To start off, to give you a very quick introduction of Atlas Copco. Atlas Copco is a well-known name, but something of which we want to present to you. It's a matter of great pride that we are celebrating 150 years of our existence this year. So, company has been established in 1873. It's a Stockholm-based company, and we have our presence in almost all the countries in the world. Overall, the group has around 39,000 employees, and we are, spread across everywhere, wherever you find this. And we are also the first company in the world to bring out the screw technology in blowers. And in India, we are present for more than 60 years. We do have a couple of plants manufacturing compressors and blowers. We have been doing that since 1960s.
Mr. Saurabh, just a minute,
Yes.
I'm interviewing. Can someone from the group let me know, is there an echo in the sound? Just put, if it's sounding okay, just put your comment on the chat box.
Is my voice echoing or is the slides having a lag, something like that?
No, there's a sound echo. Just a minute.
Okay.
Okay, we'll proceed. Thank you.
Okay. So without wasting any further time, let's get into the subject that we have. The wastewater treatment is now, as Veronica mentioned, it's a point of a lot of concern. It's no more a kind of good to have. It's a must-have thing for each and every plant, each and every business. With the increasing stringent pollution norms coming in, it's more imperative that we treat the water properly. And when we say treating the water, it calls for a long process, and we know that in some cases it goes to 3 or even 4 stage process, wherein you have a primary treatment and then a secondary treatment. So in most of the process, what is common is that it's an aerobic process. That means it needs oxygen for the treatment. And we find that it's quite common that we have an aeration basin. And there we find the most critical part of the entire ATPs or the wastewater treatment plant, the aeration blowers comes into play. Now this is where we want to bring the focus of our discussion for this morning today, wherein we want to understand that what are the things which defines this blower. Now, typically this is how what is the application of the blowers would be to create oxygenation in the water. Now, depending upon the quantity of water that is there, the amount of the dissolved oxygen which is required, the amount of BOD, COD which is finally required, then the amount of based on that amount of oxygen, that amount of air is being decided. And the height of the water column or the liquid column of the tank defines the back's resistance or the pressure, plus whatever the resistance in the pipeline adds up to that. Now there are certain very interesting theories which is there. Maybe you are very aware of that. That would be the higher the longer the the liquid column height, better the oxygen transfer efficiency. What we mean by oxygen transfer efficiency is that the more the air bubble takes time to reach to the surface from the bottom of the tank, the better is the oxygen transfer efficiency. And it has been also a matter of research and development that if the height of the water column is higher, then it has been also proven that the amount of oxygen which is required is much less, because the transfer efficiency is happening at a very fast rate or a much better rate. It's get enhanced. So what we mean to say is that there is a theory here. If it's in a 7-meter high tank, if as compared to a 3-meter high tank, the amount of finally volume required will be almost 59% less than a 3-meter one, provided the same quantity or quality of effluent is coming in. So that's also a matter of a great understanding, so that we understand the volume and the pressure required for the aeration purpose. Okay. So having understood that, let's proceed to understand why it is critical to understand the blowers and what does it lead to. So in a typically if it's industrial environment or even this thing, what we normally have seen is that the demand of the air is varying in nature. It's never fixed, depending upon the quantity and the quality of effluents coming in during certain part of the day. It varies. Maybe in the day shift it is higher than the night shifts, so it will be varying. And in fact, even some months where the production may be higher as compared to others, it can be seasonal, so it is varying in nature. So what we understand here is the air demand is varied. So we need to also have aligned the blowers according to the demand to give the best results. Okay. So what we have also mapped around, and we have done several audits in many this kind of wastewater plants. What it comes out as a common theme after all these measurements is that the aeration blowers plays a critical role in the overall energy mapping of the ATP plant. Okay, so almost we can say with a lot of confidence and responsibility, because based on the audit reports which we have come in, that almost 55 to 60% of the energy of a ETP plant is on the aeration blowers. So that is very high value, which will give you a perspective. Let's say typically a ETP plant it's a chemical or maybe a pharma plant which is having a standard size ETP. If the monthly bills are coming is around 2 crores per month, then almost 1.2 crores is from the contribution from the blowers. So that means it's a very high power consuming equipment that we have, because it's a 24/7. The blowers cannot be stopped. It's a process equipment, and then the efficiency, reliability of these blowers becomes very important. Then the discussion that we are going to have is that how we can add value to this process. First of all, by measurement, and once we measure, then we can further improve it. Okay, so that's the main basis of our discussion, that the air blowers are consuming almost 50 to 60% of the energy bill, which we can see to it how we can reduce this so that we have an enhancement in the operational efficiency. Okay. Now, what we have seen is that these are mostly the common blowers which are installed, which is commonly known as the wind or the trailer were often normally called as the roots blower. So these are like very simple machines, but very bulky machines, which needs a lot of foundations. It makes a lot of noise. And normally these kind of blowers are mostly seen in these kind of installations. Okay, so what we are trying to say that in these, if you see what are the different possible technologies, broadly it can be classified as positive displacement blowers and dynamic blowers. Positive displacement blowers are those wherein the volume is basically reduced to increase pressure. Typically, these are available from zero point 0.3 to 1.5 bar. And dynamic blowers wherein the kinetic energy of the air is being converted to pressure head, which is available, let's say, from zero point 0.2 to 2 bar. That's how the blower technologies are available. So right now we are going to discuss primarily on the positive displacement, which we normally find very common in the most of the water treatment plants. Now, these are the two different, possible technologies that we are going to discuss today. So let's start with what we are seeing is as a tri-loop. Now, Veronica, just confirm me whether the video is visible. Is the animation visible?
Yes, it's visible.
Okay, thanks. Now here, this is an animated view to show how our tri-loop blower operates. So a tri-loop blower is basically a displacement device. What it does, it has an inlet port at the top, which you can see in the green portion, and it has a delivery port at the bottom. It's basically displacing a certain amount of air. Now, since at the discharge end, there is an application, like here in this case, there is a water column attached to it. So there is a back resistance. So because of that back resistance, the air gets trapped at the delivery end, which is the blue portion, if you can see here. That creates a external kind of a pressure. So there is no internal pressure being developed along the length of the profile of the lobes. It's basically an external pressure. So if you remove the external resistance, it will develop no pressure. It's just a displacement device from the suction port to the discharge port. So since the entire pressure is coming up at the discharge port, you'll find a lot of vibrations and noise coming from the discharge port, right, for this kind of typically blowers. So this technology is called the external compression technology in short, wherein the entire pressure is being developed at the discharge end. Now, when we are, this is a very commonly used thing because it's a very easy to manufacture. It does not require much of an expertise, but some common problems is that of these blowers are that since it's an external compression device, the energy consumption is pretty high for a same flow and pressure. And also because of this typical technologies, the air we always know that has a tendency to go from the high pressure into the low pressure end. So what happens is that always there is a tendency of the air to flow back from the blue portion to the green portion. So as a result, we call that as a leak back. So whatever the inlet volume of the machines have been defined, you'll never get that as a delivered. There will be always a deviation to it. And mostly these with the usage of time, the lobes also gets wear and tear out. So the volumetric efficiency also drops. So that's on this technology. Whereas if you look at the screw technology, the other technology which is available in the market is a bit of a different technology where we are talking about an internal compression. Now, what's internal compression? The air along the length of the screws, there is the inlet and the outlet port, is actually progressively diminished. The volume is actually progressively diminished to have a rise in pressure. So here the compression is internal, it's mostly adiabatic, and that's what is giving us the better efficiency. And as you can see here very closely, although the screws seems to be touching with each other, but they are actually not. There is a very minor clearance or a gap being kept, and they are driven by the gears which you can see here. The timing gears are actually driving the male and the female rotors. So as a result, there is no wear and tear happening in between, and the air is actually internally compressed. So what happens with with this? Let's have a closer look. That if we all know the area under the PV diagram or for any machine is the work done. So this is typically of the thermodynamics of the tri-loop blower, where the area under the PV diagram represents the work done. Similarly, if we see for a same thing for a screw blower, the suction is happening almost the same thing, whereas the compression, if you see, is more adiabatic, and the green portion, what you see here, is the difference in the work done or the power savings that we have here. Okay. So now we do manufacture both these kind of blowers, and we had actually a head-to-head test of our own make low blowers, of our own make screw blowers, and we did that in presence of a very renowned certifying agency called TUV. Now, what we did is both these kind of blowers were tested at different pressures with same flows by means of a VFD. So let me show you the results in a closer way. So at different pressures, these were tested. So at 0.5 bar and 0.9 bar, ZS means the screw blowers and ZL means the low blower, just for you to understand. So what we have, what the data came out, what the results came out for all these repetitive tests is that at zero point 0.5 bar, a screw blower is almost 24 to 30% more efficient than a low blower. And when the pressure goes up, the difference further increases. So let's say at 0.9 bar, the difference will be as high as 35 to 40%, which is a substantial difference. So let's say we are talking about a 0.9 bar of application for a low blower. If you replace that with a blower, what you can immediately expect is something like 35 to 40% savings on your energy bill. So we also had a kind of a thing on the VFD part of it. Now we showed you we knew that based on all our measurements that the air demand is varying in nature. It's never fixed. And we have seen that most whenever the installations are there, most installations are with VFD, but the control is not happening in a closed loop. What is happening? The VSD is being manually controlled, and as a result, either more air is being delivered or less air is being delivered. It is never accurately being measured, and there is no flow feedback control loop there. So what we can do very easily with this kind of blowers is that we can accurately control the dissolved oxygen which is required in the water by means of a very simple arrangement which we are showing here. So let's assume that this is the tank where your effluent treatment is being handled, and you have a certain desired DO to be maintained. So by means of a very simple PLC, you can just program it the desired set point oxygen can effect, and the DO sensor has to just give an analog output in form of a 4 to 20 milliamps. If that is possible, then that signal can be directly hooked up to the VFD, and the VFD can give you the exact amount of air which is required to maintain the DO at that instant of time. So what advantage will you get? Let's say you have taken a blower which has got a huge turndown, a turndown of more than 70%. When I mean by turndown is the minimum flow to the maximum flow. Okay. Now at that thing, though, if you can actually meter it, let's say if you can actually get a signal wherein you need to only deliver 1,000 meter cube, then your power consumption, as the curve suggests, you will only be consuming proportional to whatever is required 1,000 meter cube. And if it is, let's say, it's giving a signal so that it will run at 2,000 meter cube, then the power consumption proportionally increases. So which will give you a very accurate, measurement of DO, and also the power consumption substantially comes down, and there is no manual intervention here. It's a completely automatic closed loop control of how the VFD is going to operate. So this will, I'm just giving you a perspective. So let's say if there is a demand of varying nature from 1,000 to 3,000 meter cube. So this is how a VFD can actually work wonders for this kind of an application, an integrated solution like this. Okay. So let's get into one of the practical examples. Let's say we have a situation where there is a very varying nature of demand, let's say from 675 to 3,400. And let's say typically a demand is there at 3,000 meter cube. Now, when we audited the existing installation, it is with a 110 kilowatt tri-loop blow. Now, which we can, we are contemplating to see that what we can do a possible solutions. So if you can see, we can achieve a 675 to 3,400 at 0.7 with a 75 kilowatt blower, wherein the total power, the total package power of the blower can be around 66 kilowatt. When we measured that for the existing blower, it came around something like 96 kilowatt. When we measured from the existing installations. what the difference straight away comes out is around 30 kilowatts. Huh? And as I told you, it's a continuous duty blower. It cannot stop. So if you just put the mathematics correctly, so you have a straight away savings of around more than 22 lakhs per annum on the operational cost. So that's the kind of efficiency and the operation flexibility which it can brings you, which is such a huge rundown. And again, this can be controlled in a direct loop as we have shown in the earlier slide with the VFD. Okay, now these are available in various pressure variants starting from 0.6 to 1.5 bar, and it can comes with as low as 18 kilowatt to around 355 kilowatt. It also has a very wide range of lows starting from as low as 700 meter cube. It can be as high as 9,300. This is the possible things. Okay, so on foundations, it can be just placed at the application end. You need not have a very heavy foundations. So most of the civil work, even the actually a room is also not required. I'll show you a few of our exact existing installations wherein these blowers are actually placed with a rain protection canopy so that the rainwater does not go inside. And this is absolutely a fine installation, so that you can save on your civil cost also in making a room. So it gives a very wide turndown of 70%. All the blowers are here cooled, even for the 1.5 bar variant. So there is no need for any additional utility or water to be provided. We have shown that the VFD works perfectly fine with the 44 to 20 milliamps from the DO sensor and can be hooked up. And so this, and also this comes with a very silent operation with canopies and all. So the actual noise will be less than 78 decibels also. So this is, and this also comes with a very enhanced microprocessor-based control, which has, or which will give you all the possible outputs of the thing, and it will also give you all possible connectivities, whatever you can think of. You can directly take those data to your laptop or even to your mobile, and it can give you triggers or alarms when the blower needs a bit of a service. Okay, so when the service interventions are required. Now, this is something which will give you additional, flexibility and peace of mind while in operations. Okay. So just to summarize whatever we discussed from today, that for in any ETP plant, aeration blowers are of extreme importance. Why? Because these are 24/7 and it consumes almost 60% of the electricity bill comes from the aeration. So it is most imperative that we give some attention and focus on the power consumption of this. So if you can reduce like 30% of the blows, that can actually translate to a lot of operational savings. Okay. If the operating pressure is somewhere around 0.5, 0.6 bar, you can be very sure that you get 30% saving. If the operating pressure is higher, if you have a higher liquid column, then one side it will have a better oxygen transfer efficiency, and also it will have if you're replacing with a screw blower, the power savings can be as high as 40%. With a VFD control, with a DO meter, actual closed loop feedback can be set, which will further enhance the accurate controlling of the DO, so that there is no excess water or excess air or less air being supplied. Actual quantity can be supplied, which will further proportionally reduce the consumption, and the efficiency of the operational plant can be increased. And this blowers comes with, as we can say, 70% turndown. So one blower can give you a very wide turndown. It can be installed just close to the application area where your UTP tanks here, and it can reduce the noise, and it has got much better control and monitoring with all IoT based control, which is possible, right? Okay. So, and the best part is the performance does not get derated. So as we have shown that it's an internal compression, and the screws actually don't, the profile does not actually come in wear and tear. It's being driven by timing gears. So there is no physical wear and tear happening in the rotors. So you can get a guaranteed flow throughout its life. So there is no degradation of the performance that are on the blowers, which gives you a lot of reliability to the application which is being put. Just to give you one of the perspective that if it's a typically a 3000 meter cube demand at a 0.7 bar kind of requirement, if you are having a presently installed low blower, then if you can measure it, like the first step to for any improvement is to measure it so that we know what's the initial data, and then we can propose a replacement. Many times we have seen that after doing that, the energy bills have gone down by more than 22 lakhs. So that's something we are trying to bring in to your table. That's and also this will also help you to reduce the carbon footprints. What we are like, we are also having a responsibility towards planet. Now, if you are replacing one low blower with one screw blower, then that effectively means that you are planting around 2,000 trees. That's the amount of carbon footprint that it can save. That's the potential of the screw blower that it can save. So that's the overall summary. So these are a few things that you can consider if you have an existing plant, and if you want to, if you have some existing tri-lobe or twin-lobe blowers, where we can, the first step would be we will always recommend to go for an actual measurement, a kind of an audit. And once we understand that, then we can propose it, and we can have a very fantastic savings in your operational cost on the overall ETP.